Okay, class, in this lesson, you're going to learn to identify and describe geometric sequences from arithmetic sequence. So let's go ahead and get started. All right, so a geometric sequence is a sequence of numbers in which each term after the first term is found by multiplying the previous term by a common ratio. Okay, so let's say that in this geometric sequence, we start off with 3. Well, how do we get to 2 from 3? All right, and then how do you go from 2 to 4/3, and then 4/3 down to 8/9, and then 8/9 down to 16/7? Well, the way we do that is we're going to take the second number and divide that by the first term. Okay, so we'd find that the ratio, we're going to call this common ratio, is equal to 2/3. Okay, so let's go ahead and test this out. So if we take 3, which is our first term, okay, and we multiply that by 2/3, we get 2. All right, so that's the second term. Then we're going to do the same thing again. We're going to take the second term and we're going to multiply that by 2/3. And when we do, we get 4/3. Okay, and you'll see that that's the third term. And let's just test it one more time just to make sure that this is correct. We're going to take that third term, which is 4/3, and we're going to multiply that by 2/3. And that works out to 8/9. Okay, and as you can see, 8/9 is exactly the term after 4/3. All right, so the key thing here is the common ratio. All right, so whenever you have a scenario, a sequence of numbers, and they progressed based on a multiplier, in this case 2/3, then this becomes a geometric sequence. Okay, all right, let's take a look at at this next series, our next sequence of numbers. Okay, so here we got 3 to 4.5 to 6 to 7.5 to 9. As you can see, to go from 3 to 4.5, we are actually adding 1.5 to get to our next term. Okay, and then if we take the second term and we add 1.5 again, you see that that takes us to 6. And if you were to test that out for the next two terms, you'll see that you'll land at 7.5 and 9. Okay, now this sequence, because we are adding, is not a geometric sequence. This is what's called an arithmetic sequence. Okay, so arithmetic sequences involve adding or subtracting, and then geometric sequences involve multiplying or dividing. Okay, so let's go ahead and go on to this example 2. Okay, this is what's called a recursive formula. And the recursive formula helps us to identify the next term given a particular term, as long as you have the common ratio. Okay, so the recursive formula states that the nth term, okay, so let's say we're looking for the third term, okay, a sub 3, let's say we're looking for that, that is equal to the ratio or common ratio times a sub n minus 1, meaning the term before the third term. So n minus 1 would be 3 minus 1, or the second term. Okay, so if you take a look at the sequence, okay, we go from 8 to 12, and we want to figure out what the third term is. Well, here we know it's 18, okay, but first we want to find the ratio here, okay, and the ratio works out to 12/8, or simplifies to 3/2, okay? So what that means is if we take 8 and we multiply that by 3/2, this works out to 24 over 2 or 12, which is exactly the second term, okay? So then the recursive formula states that a sub third term, in our case we're looking for the third term, is going to equal the common ratio, which we just solved, 3 over 2, okay, times a sub 3 minus 1, which is the second term, okay? So this works out to 3/2 times the second term. Well, what's the second term? Second term here is 12, okay? 12 right here. So we go ahead and substitute a sub 3 minus 1, which is the second term, which equates to 12. And if we were to multiply this out, this becomes 36 over 2, which is equal to 18. Okay, so the recursive formula helps us to identify a particular term given the previous term. Okay, it's a good formula, but it is a little bit limited. The next formula actually is a little bit more powerful, and that is the explicit formula. So the formula we just learned was called the recursive formula. This formula is called the explicit formula. An explicit formula is as follows. A sub n, so whatever term you're looking for, is equal to the first term in the sequence times the common ratio raised to the n minus 1 power. Okay? So if, for example, let's say we're looking for the 10th term of the sequence. So we have 1, 2, 3, 4, 5. And we'd have to multiply it out 5 more times to get to the 10th term, which is not too bad. But if we're looking for the 50th or 100th or the 1000th term, the exercise of using the recursive method would be very, very, very cumbersome. Okay? Now, if we had the explicit formula, then we could say the 10th term is equal to the first term times the common ratio raised to the 10 minus 1 power, or 9th power. Okay? So in other words, a sub 10 is going to equal the first term in this sequence, which is 8, times the common ratio, we haven't solved that yet, but I'm going to leave that blank, to the 10 minus 1 power. Okay? So let's go ahead and solve for the common ratio. The ratio is going to be equal to, I'm going to take the second term divided by the first term, and that works out to 3 over 2. Okay, so then we know that our ratio is 3 over 2, and then we go ahead and punch these numbers into the calculator. We would find that it is equal to the 10th term is equal to 307.5. Okay? So that's a quicker way to find a particular term in a geometric sequence. Okay, let's take a look at example 4. All right, so we're going to apply the recursive and explicit formulas. So we're going to see both formulas in action. Okay, so imagine you have $100 in a savings account and it earns 5% interest every year. Okay, so the question is, how much will you have after each year for the first 5 years? Okay, so let's go ahead and solve for that. So we're going to say that A sub 2, okay, so we're looking at sub 2 because we're looking at the end of the first year, or which is the equivalent of the beginning of the second year. Okay, both are the same. So A sub 2 is going to be the common ratio. In this case, it's going to be 1.05 because we're looking at 5% earnings on top of the initial amount of $100. So we have to multiply that by 1.05, not 0.05. And this is going to be multiplied by the initial investment of $100. Okay, and this works out to $105. Okay, and then the following year, this is the end of the second year or the beginning of the third, is going to be, again, the common ratio, which is 1.05, and this time we're going to multiply this by 105. Okay, and this works out to 105 times 1.05 works out to $110.25. Okay, and then the next year we're going to do the same thing again. 1.05 times, this time it's going to be $110.25, and that works out to $115.76. Okay, and then the end of year 4 or the beginning of year 5 is going to be 1.05 times $115.76, and that works out to $121.55. And then lastly, at the end of 5 years, or the beginning of the 6th year, it's going to be 1.05 times $121.55, and that works out to $127.63. Okay, so these are the values after the end of the first year, at the end of the second year, the end of the third year, the end of the fourth year, and at the end of 5 years when invested at 5%, beginning with $100. Okay, so let's take a look at the next part of this problem. How much will you have in the 50th year? Okay, so this is the beauty of the explicit formula, because I can find the amount in my 50th year by multiplying the initial amount, which is $100, times 1.05 to the 50 minus 1 power. Okay, so if you punch that into the calculator, that works out to $1,092.13. That's how much you will have in 50 years, investing $100 at 5% interest every year. Okay? All right, so that was it. Hopefully that made sense. If any of this was confusing, please go back to the beginning of the recording and listen to it again. Thank you.